Now let us try solving the sixth question, where you are told that initially you are given an amine X with molecular weight 740 AMU, and when it is treated with CH3 C double bond OCl in the presence of pyridine, you got a compound with molecular weight 1076 AMU. So now you are asked to find out the total number of amines in the given compound except tertiary. So let us first see the reagent given to us. It is CH3 C double bond O Cl in the presence of Py, or pyridine it is. Py indicates pyridine. Now if you remember from your theory, this is acylating agent. That is, it introduces acyl group for any compound. In this example, it is for amine. That is C double bond O group. It introduces this group. Now let us see what happens actually. First consider an amine, say R, N, R dash, H. Now this R dash can also be H. That is, it can be either primary or secondary. First, if you treat it with CH3 acyl chloride in the presence of pyridine, this is going to attack here, and you know that this is strong electrophilic group site, and this leaves up. You know that oxygen is not good leaving group, so it again comes back, and finally Cl, since it's a good leaving group, departs away, and you are going to get this compound like R, N, R dash or H, C double bond O, CH3. Now observe the initial compound and final compound. This is the final one, and initial one is Rn, R dash or H. Here you have just H. Now if you see, let's try to find the molecular weight difference between these compounds. If you observe, this group is same for both the compounds. The only difference comes from these two groups, whereas in the product you have C double bond OCH3, and in the reactant you have just H. So the difference between the molecular weights of these two compounds is the difference between the molecular weight of C double bond OCH3 and H. So let us try to find it. That is, you have to find molecular weight of C double bond OCH2. It is 12 into 2, which is carbons, and 16 into 1, which is oxygens, and 2 into 1 AMU, which is equal to 42 AMU. That is, upon acylation, for at one primary or secondary, you are going to get a change of 42 AMU in molecular weight. Now let us come to the question where you are told that initial molecular weight is 740 and final molecular weight is 1076. So the total difference in the molecular weight is 1076 minus 740 AMU. It is difference. Now it is equal to 336 AMU. You know that for one acylation, you are going to get a molecular weight of difference of 42 AMU. For some say Y acylations, you are going to get this 336. Now you are going to find the Y, which is nothing but the number of primary and secondary amines. That is, Y is equal to 336 upon 42, which is 8. So you can say that on the whole there are 8 amines which are not tertiary. Now at this point I want to discuss about acylating agents. You have acylating agents like CH3, C double bond O, Cl, it's the first one, and you also have acetic anhydride, this one, and acetic acid, not acetic acid, this is ester. Oh, for example, let's say C2H5. Now all these are in pyridine, which is a solvent here. Also one more thing which is already told in the theory, we are not using aqueous solvent here because in the presence of aqueous solvent this acyl group, that is, I'll show it here, this group hydrolyzes. So you are not using aqueous medium. Now let's see what happens if these 3 groups are there. Now you are asked to find out which is good acylating group. Now if you see, for the first one the leaving group is Cl minus, and for the next one you have CH3, C double bond O, O minus, and last one we have C2H5, O minus. Now leaving ability for Cl minus is greater than this, is greater than C2H5 O minus. This is because if you remember, HCl acidic strength is greater than CH3 COOH, which is carboxylic acid, is greater than alcohol. So corresponding conjugate base strength, that is Cl minus, is less than CH3 C double bond O, O minus, C2H5 O minus. This is just the conjugate acid base theory concept. That is, this is less reactive. Because it is more stable. So this is good leaving group because when it leaves it is not going to react since it is less reactive. So the reactivity order is this greater than this anhydride greater than this ester. This is what we want to discuss here. Now let us move to the next question. Now let us try to solve the 7th question, which is very small one, where you have to obtain just methyl orange indicator. Now to do this you must know what methyl orange indicator is. First let us try to draw the structure for it. The structure of methyl orange indicator is this one, double bond N, where you have N, CH3 and SO3 minus Na plus. This is methyl orange indicator. Now let us see how it is obtained. Now observe carefully, you have N double bond N here and 2 phenyl rings here. Now this shows you that some sort of coupling has occurred here. So first let us see how this coupling has occurred. Let us start with this compound where you have NH2 here and para to it you have SO3 minus Na plus. Now if you treat it, you have to treat it with NaNO2 in presence of HCl or HNO2 you can say. Also remember it occurs at temperature 0 degree centigrade. Now you won't be asked it in the exams, but for your sake I am telling you this. You are going to get this compound. The mechanism of it is already taught to you in the previous questions. N plus Cl minus. Here you have SO3 minus Na plus. Now as you can see, this is an electrophile and it couples. Now let us consider this part where you have CH3. Let us consider this one. Now if it couples, you're going to get your methyl orange indicator. It's very simple. You have this one, N double bond N, and you have N CH3, and here you have SO3 minus Na plus. Now let us see how this methyl orange indicator actually shows color. It's very simple. Now this is actually yellow in color. You know that in acidic medium, that is in H+, it changes to orange red color. Let us see how it actually happens. You have got this compound, that is H+. H+ is going to attack on this side. Where this bond is being shifted in this direction, you are going to get NH and this one, and CH3, and here you have SO3 minus Na plus. It would be more clear if instead of putting this ring, if you write this one. Also you have positive charge on this nitrogen. Now I'll tell you why it attacked on this side rather than this side. As you can see, this SO3 minus is strong electron withdrawing group, and it creates positive charge on this carbon, on this nitrogen. So attack on this side will give you a positive charge here, which is more destabilized, but attack on this side will shift the bond in this direction, that is in this direction. So you're going to get negative charge here, and it is attacked here. Also this nitrogen is electron donating, which stabilizes this positive charge. I'll show it to you here, and you're going to get SO3 minus Na plus, this ring, you have NH and N double bond and this compound double bond N plus here. This is orange red. So this is how methyl orange shows color variation in its compound. As you can see, you may ask me why I have started with this compound, that is initially with this, but not with say this compound. That will be clear to you if you look into the next question. As told in the previous question, let us see this 8th question, where you have to arrange the following diazo cations in the increasing order of their reactivity towards diazo coupling. Now, for example, let's take any coupling reaction like this one. Say you have got OH here, and you have got this diazo compound N2 plus. Now say you have substitution here. Now you are going to get a coupled product like this one, where you have N2 here and you have X here. Now observe carefully, this is electrophile, right? So this electrophile has to be more electrophilic for the reaction to occur fastly. So this should be more electrophilic. Now as you can see, for the 4 given set of compounds, for the 4 given diazo cations, the substrate on which they are going to act is going to be same. That is, say this one, or you can even have NH2 here. Or so the substrate is going to be same. That is, the electron donating capacity of, say, either this one or this one for all of these is going to be the same, and the reactivity will depend upon the electrophilic nature of these cations. That is, since nucleophilicity is same, reaction depends upon electrophilicity. Now, that is, in the given 4 compounds, the compound which is more electrophilic, that is, which is more lacking in electrons, is more reactive. Let us name this as 1, 2, 3, 4. Now, as you can see, this OCH3 group and this an Me2N group. I'll write it OCH3 and Me2N. These are both plusr groups. That is, they donate electrons and thereby stabilizes the positive charge. So the resulting one would be less electrophilic. So obviously they are not going to come first. And next one which you need to take care is in between these two, which is more electrophilic. Now if you observe, nitrogen is less electronegative than oxygen. Electronegativity order, if you take, nitrogen is less than electronegativity of oxygen. So this nitrogen can donate electrons more easily than this oxygen. Also observe that this nitrogen has 2 methyl groups, and because of presence of these 2 methyl groups which are electron donating, it can donate this charge, this lone pair, more effectively. So you are going to get that is this compound on the last, that is third would be the last one. Now let us, so second would be the second last one, or not second, what is this? No, the first one would be the second last one. This is first one, not second. And let us compare between the remaining two, where you have NO2 and you have CN. You know that if you remember from your GOC, minus R order for NO2 is greater than CN. This is because this nitrogen has more tendency to pull the electrons, because electronegativity for nitrogen is greater than electronegativity for this carbon. Also, this nitrogen shows more minus I. That is, in both the cases, if you take either minus R or minus I, this is better in presence of the minus concept. So this is going to be more electrophilic. As a result of it, you are going to obtain second one first, followed by fourth one, and then 1, and then 3. Now by now you'll be able to understand why I have chosen for methyl orange indicator this one, which is SO3 minus Na plus NH2 here. As you can see, from this you are going to get this cation. Now carefully observe that you have 2 S double bond O groups here, which are strongly electron pulling groups. This pulls the electrons, and also this, since it is dragging these electrons towards it, you are going to get more positive charge here. So this is more electrophilic. That's why I have used this one but not this one. where you have NH2 here and NMe here. So now that we are done with this question, let us try solving the next question. Now let us try to attempt this ninth question, which is a matching, where in the first column you are given amines, which a set of 2 amines, and in the second column you are asked to find the test that can be used to distinguish between the 2 amines. So let us see how to approach this problem. First, let us see what these tests are. The first one which you have is carbylamine test. Now you all know this test very well from your theory. Just recapitulate it. You can have only primary amine, and also remember that this can be, that is RNH2. This R can be pH also, so PHNH2 is also possible. And secondary, tertiary won't give reaction for this. Now the second one given to us is azidoitis. That is azidoitis. Now let us see what this test is. First, this is just similar to a coupling reaction which we have discussed, and here it's used to test primary aromatic amines. Let us see how it is done. Suppose you have any primary aromatic amine, say PHNH2. You treat it with NaNO2 in the presence of HCl, or even this is same as HNO2. You are going to get a Diazo compound, which is PH N2 plus Cl minus. Now up to here, this is called diazotization. Diazotization this is. Now this is the first part in this one. Now the second part includes treating this with beta naphthol. Now let's see what this beta naphthol is. You all know the naphthalene pretty much. The naphthalene structure is this one. Now you are told that beta here, this is alpha position and this is beta position, and the functional group here is OL, indicates OH group. So this is structure for beta naphthol. Now in this, the alpha carbon is ortho to this OH group, so this electrophile attacks here. Also observe that it cannot attack on the para position, which is more preferable because it's blocked here, and it preferably attacks at this ortho position because this one is more stabilized than this one. Try to draw the resonating structures for it and you will come to know it by yourself, and you are going to get this one where you have OH here and double bond and pH. This is orange dye. This reaction is called as Diazo coupling or Diazo test. That is, it's used to test for primary aromatic amines. Now let us see what the third test which is given to you. The third test is Hinsberg reagent. Now if you remember from your theory, or if not, just go back, turn your pages and see what it is. For Hinsberg, primary reacts completely, secondary responds to half of the test, whereas tertiary doesn't react at all. So if you have any of the amines, say any of these three, any two of these three, that is primary, secondary, primary, tertiary, or the other possible combinations, you can distinguish between them. So it can be used to distinguish any two of these three. Now the fourth one given to you is Lieberman's nitroso test. Now again, if you remember this Lieberman's nitroso test is used for secondary amine in the presence of HNO2. That is, you are going to get yellow oily liquid. The test is called as Lieberman's nitroso test. So it is given by only secondary. It can be either aliphatic or aromatic, and primary, tertiary won't give it. Now let's try attempting the question, where in the first one you have this one primary amine, and this one is also primary. This is aliphatic and this is aromatic. Now carboylamine test fails for it. So let's write it in this way, PQRS. So for this, carboylamine test fails because it's given by all the primary irrespective of aliphatic or aromatic. Now azodite test responds because it gives only for aromatic primary amines, and similarly you can say that R also won't give it, and Lieberman's nitroso also won't give it, since there is no secondary. Now let's come to part B. If you see it, this is tertiary and this is secondary. So carboylamine test won't be given by both of them, so this fails, and azodite test won't be given by either of them because there is no primary aromatic amine here. Now the third one is Hinsberg. Hinsberg can be used to separate any two of the three amines which are discussed before. Now the fourth one is Lieberman's nitroso. Here you have secondary and tertiary, so you can obviously distinguish them. So now in the C part you have a primary and a tertiary. First one is obvious because it's carboylamine test given by primary amine, and if you see Q azodite test, it's not given because it's given only by aromatic primary amines, and there is no aromatic primary amine here. And if you come to R, Hinsberg reagent can be used to distinguish any of them because this is primary and tertiary and not same. And the fourth one is Lieberman's nitroso. It cannot be used because there is not secondary here. Now if you come to the last part where you have tertiary here and primary aromatic here. Now first carboylamine test can be used because you have primary, and azodite test can be used because you have primary aromatic, and Hinsberg can be used because one is tertiary and one is primary, and Lieberman's nitroso cannot be used because there is no secondary here. So the final results for it would be, for A you have only Q, I'll write it here. For B you have R comma S. For C you have P comma R, and for D you have P comma Q comma R. So this is the way you have to approach this problem. Whenever these kind of questions are given, where you are given some amines and you are given some tests which are used to distinguish them, you have to first know what the tests are, carefully observe them, and what the substrates that we are using here, make a list of them, and step by step solve this in detail. Only then you will be able to obtain the solution for it. So now let's move to the next question. After that we are done with 9 questions on amines. Let us try solving this last question, where just like the previous question, it's also a match the following type. In the first column you are given some set of compounds, and in the second column you are given some reactions, and some of the compounds of the first column shows the corresponding reactions in the column B, and you are asked to find out which compound shows which of the reactions. Also remember that just like the previous question, more than one option may be correct, so you have to do this very carefully by identifying what the reactions are. First let us see the first one. where you have sodium extract, which gives you a Prussian blue color. Now, if you look into this, the sodium extract will remind you to your separation of organic compounds, which you will be taught in the starting of organic chemistry. If you remember, in the identification of organic compounds, not the separation, in the identification of organic compounds, first we'll treat the given organic compound with sodium extract. That is, whenever you treat it with the organic compound with sodium, you treat it and you are going to get sodium extract. Now just try to recollect from that. If there is nitrogen in that organic compound, then with FeSO4 it will give you blue color. Remember, you are going to get blue color if there is nitrogen. The symbol for there exists, which you will be learning in your maths. Now, so for the P, you should have organic compound with nitrogen. Now this is very important, the thing organic compound. This test shows only for organic compounds but not for inorganic compounds where there is no carbon. Now the next one given to you is positive FeCl3 test. Q is FeCl3 test. Now this test you are already taught in your previous sessions, where in your phenols, if you recapitulate from the oxygen containing compounds, you will be shown that this phenol will give you the test. This is given by phenols. So if there is phenol in the ring, if there is phenol in the molecule, then you can say that it gives you positive FeCl3 test. Now the third one which is given to you is white precipitate with AgNO3. Now AgNO3, here you have cation Ag, and whenever you are talking about precipitates with Ag, you should learn three things. One is Ag with Ag plus with X minus, where suppose say this X is chlorine, bromine, iodine. Say it has Cl minus, and once you have Br minus, and in the third case you have I minus. Now if you consider these three cases, you are going to get first AgCl, and next AgBr, and next AgI. This AgCl is white color, and if you observe, the color of AgBr would be pale yellow, and the color of AgI is yellow. So here you are told that you are getting white PPT, and all these are precipitates. So white PPT indicates the presence of Cl minus. So first check in the compound for Cl minus. So that is for R, we shall do it again, we shall do it later. There should exist Cl minus. This is the criterion to satisfy the third one. Now the last one which is given to you is reacts with aldehyde to form hydrazone derivative. Now let us see what this is. You will be taught this in your carbonyl chapter, and already you are taught that one. Let us just recapitulate what it is. Suppose you have aldehyde, say C double bond R C double bond OH. If you treat it with NH2, any RNH2, R can be any group, then you are going to get, let us take it in this way, R C H double bond N R. Now this is hydrazone derivative. Now here you are given reacts with aldehyde to form hydrogen derivative. So in the given molecule there should exist NH2, RNH2, that is some primary amine should exist for them. Now let us try to attempt this question with this knowledge. First, just like the previous one, let's put in this way PQRS. Now see, for the first molecule NH2 NH3 plus Cl minus, the first one is sodium extract gives Prussian blue with FeSO4. Now here we are pointedly told that it gives blue color if and only if you have an organic compound which containing nitrogen. Here the compound has nitrogen, that's no problem, but it's not organic because it doesn't contain any carbon. So first test fails for it. And now if you look at option Q, which is positive FeCl3 test, it is given by, I have already told you, phenols. So there is no phenol here, so it won't give it. And white PPT with AgNO3. Yes, you should have Cl minus, you have Cl minus here, so you're going to get AgCl, which is white PPT, so R is correct. So you will get AgCl, which is white, just we have told in the previous thing. And coming to the S, reacts with aldehyde to form hydrogen derivative, you should have NH2. Here you have NH2, so S gives. Also note that here we are told that there should exist RNH2, and here this R need not be CH3 or pH. This R can be anything, we have told that. Either this, just like the previous one, it can be NH3 plus or Cl minus, or it can be even any organic molecule or inorganic substituent. So the R need not be organic here, keep it in mind. So since it has NH2, the only criterion is to have NH2. So this gives it. Now let's come for option B. Sodium extract gives Prussian blue. Here you have organic compound, it has nitrogen, so P responds for it. And if you see Q, positive FeCl3, it has OH group attached to, that is phenolic group, so Q also responds for this, also responds for Q. Now let's come to R, where you have I minus here. The precipitate which you are going to get here is AgI, which is yellow in color. So but you want white precipitate, so it won't give. And the next one is aldehyde, you should have NH2 group. Here you do not have NH2 group, rather you have NH3 plus I minus, as shown here. You have, that is, no free NH2. As a result of it, S also fails for it. It fails for S also. Now let's come to the third part, where first you are asked for sodium extract. Yes, it gives because it has nitrogen and it's organic compound. And next, positive FeCl3, it has phenolic group, so it gives it. And white PPT with AgNO3, but AgBr is pale yellow in color, so you are not going to get this one. And last one is you should have NH2 group. The same is the case with B. This is as a very similar case. You are not having free NH2 group, so this also fails here. Now come to the last part, where you have this compound. The sodium extract for this compound, it gives because it's organic and it contains nitrogen. Positive FeCl3, no, because it doesn't have any phenolic group. And white PPT with AgNO3, no, because it doesn't have Cl minus ion. And aldehyde reacts with aldehyde to form hydrogen derivative. It has free NH2 group, so it can give. So let us write what we have finally got. For A, you have got R comma S. For B, you have got P comma Q. For C, you have got P comma Q. For D you have got P comma S. So this is how you have to approach this question. Now that we are done with the amines chapter, now here I want to tell you few things. As far as amines is concerned, here this would be somewhat new topic because here you are involving the basic nature of amines, and I want you to practice the reaction mechanism as many times as you can till you got grip in the subject. First, try to solve every question or every reaction which is given in your textbook or in the theory part which we have given with the mechanism, unless it's somewhat inorganic type reaction or very hard mechanism involved in it. So if you try in that way, you'll be benefited more. And as far as questions are concerned, in IIT JEE you'll be asked only small questions, don't worry about it, and you will be able to solve it if and only if you know the concept for it. Otherwise you cannot tackle these type of problems. So first, be thorough with the mechanisms and try to solve every question with mechanism. So here we end up this chapter. So let's continue with the next chapter.